Alright guys, welcome to another video of me solving questions on contests, and today we will be solving biweekly contest 171. So yes, let's go. Okay. Okay, so the first question is medium, and you are given integer nums and a number num. Okay, I am given a num. Okay, a number is called a complete prime number if every prefix and suffix of num is prime. Wait, what? Every prefix and suffix? Okay, I think he's talking about the digits. So return true if num is a complete prime number. So if every prefix and every suffix of num is prime, what does that even mean? Every prefix, let's talk about this. Prefixes of 23 is 2 and 23 is okay, so all of the prefix should be prime. Okay, got it. Okay, return true if num is a complete prime. Okay, so num can be up to 10 to the power 9. Alright, so yeah, I can just do, because the number can be at most 109. So what can we do to find if all of the suffix is prime or not? How can I find the prime of suffix and prefixes? Okay, when can it, for each of the prefix, so how many prefix? So there will be almost order of 9 prefixes or suffixes, right? There can be at like how many prefixes? Like at most 9 prefixes. 10 prefixes, sorry. 10 and suffix also 10, correct? So for each of the number that I get, I am just going to do a normal check if it's a prime or not. That's what I'm going to do, and I can just do like square root of n in order to get all the factors and check if any of the factors divide it or not. If it cannot divide, then I can just say that it's a prime number. But so this square root of n can at most be square root of 10 to the power 9, which is almost 10 to the power 5. So 10 to the power 5 times order of 9, which is doable. Yeah, so yeah, it's doable. So I think I should do it. Okay, so before I try to do it, one thing that I can do is to convert this to string, and then convert the string to num. Correct? That's what I can do. But yeah, that won't be taking a lot of time, because this will be at most 10 to the power 5, and the constant, it's not going to add much of it, right? So yeah, let's try to do, and let me not change this, let me keep that. And yeah, so let's say string s is equals to string num, and the prefixes, yeah, the prefixes. So for I equals to one of the prefix that is suffixes are 3 and 23. So yeah, this 23 is actually we can count it in the suffix as well as prefix, so I don't need to count it twice. So I can just directly say this, right? What are the suffixes? So if you start from 0, the suffixes are starting from 1, 2 and to the end. and the prefix I'll already have the prefix. So let me do this. Pref is going to be s dot sub str from 0 to I minus I plus 1, correct? That's what prefix is going to be, and the suffix is going to be s dot sub str. Okay, I also need to convert it to integer, right? So let's convert this to integer and this to integer as well. So s dot sub str from I plus 1 to n minus I, correct? Minus 1, n minus I minus 1 is actually going to give, n minus I is going to give you the yeah, this is correct. Okay, so now what do I do? I just check this from starting from 2, I times I is less than equals to n or pref I plus plus, and also I'll check for the stuff as well. So if I found if I okay, so the first thing, if pref is already 2, then obviously it won't make a difference because 2 times 2 is 4, and it's greater. So so pref modulo I, because, and also it can be 1 as well, right? So if it's 1, I need to just give false, right? So if anywhere I found 1 or something like that, I'll just return false because it's not a prime number. So if pref is 1, I'll do or suff is 1. So in the end, if you look at suffix is just going to be nothing, correct? Like in the end, like when I reaches to n minus 1, prefix is going to take over, there will be just no suffix. Then I really don't want to do, so I'll be like, okay, so that's not a suffix, right? So I think I need to, because I cannot have 0, I think that will give me an error. So let's see what I can do for that edge case. Okay, so if prefix of I is divisible, okay, and this is, I need to return false, correct? And now here if prefix, and prefix, if you look at prefix can never be a non-existence, it will always exist. Only the suffix will be sometime non-existent. If I can divide, it's not a prime number, and if it's not a prime number, I can just say, return false, else I just keep on doing it, and then I'll try to be like, okay, now let's see what we can do about the suff. Okay, so suff I have already done this here, so let me change this thing a little bit. Okay, I'll be like, okay, if s dot string, or maybe string new, or maybe t equals to s dot sub str I plus 1 I minus 1. Okay, and now this t if okay, right, if t dot empty, then if not empty, I mean, then what do? I check the same thing again. If t is not empty, then only I do that. Well, I don't think that there will be an error if this becomes 0. Will there be an error? So that's why I think I need to be cautious about that. Okay, So int suf is just going to be, you know, stoy of t. So let me remove this. Yeah, stoy of t. Okay, so many mistakes. Okay, and now I'm going to be like, okay, if suf equals to 1, then return false, and or do this thing. So I'm just going to copy paste this instead of, you know, writing it again and again. Correct? Okay, now I'll be like, okay, if this, instead of this, I'll be like, okay, suf, right? Alright, now when it has gone from the first index to the last index, the iteration is completed, then I'll just say that return true. And yeah, so it can be empty, so if it's empty, then I don't really do anything. Let me add a test case here. There's only one test case, so let me add my own test case. See. Yeah, undeclared identifier. Yeah, so I need to declare n as nums.size. Well, not num actually, and just s.length. That will be alright. Alright, now I think this is going to give a problem. It didn't give a problem. Okay, so did it give false? Yeah, it did give false. So yeah, I think we are good to go. Let's try to submit this. Yeah, it did got accepted. So let's try to move on to the next question. You are given an integer array nums. For each element nums I, you may perform the following operations any number of times, including 0. Okay, so yeah, for each element in nums of I can do this, increase any number of times. Okay, increase nums I by 1 or decrease nums I by 1. Okay, a number is called a binary palindrome, which its binary representation without the leading 0 is the same as forward and backwards. Okay, alright, so okay, a binary palindrome, right? So binary palindrome, if it has something like this, then when I do that, without leading 0 reads the same. It cannot read the same, right? Because it's just not the same thing. So if it has a leading 0, I'll highly doubt that it's not suit for it. It will not suit. So basically, it should not be even number. It can only, a binary palindrome can only be an odd number. Correct? Okay. Alright, that's okay. So I need to make all nums I not only odd but also okay, not only odd but also so how can I make it not only odd but also palindrome? Well, okay. Minimum number of operations required to convert nums I into a binary palindrome. Alright. So I need to find the minimum number of operations required to convert nums I into a binary palindrome. Okay. So what is the trait of binary palindrome? So if I subtract or if I add 1, I just need to make a binary palindrome. What if I try to find what is the next greater binary palindrome and what is the just lesser binary palindrome? What if I try to find that out? So one of the brute force that is coming to my mind is find the binary palindrome which is just less than or equal to, and find the binary palindrome which is strictly greater than that num sign, and then you just subtract whichever will give the less operation. You just take that as answer for the particular ith index and just add all of them. That's what I need to do, right? So okay, I need to, so it's 0 because it's already a palindrome. This is not a palindrome, so I need to make it. This is also not a palindrome, I need to make it. I add 3, in one operation I can make it a palindrome, correct? Okay, so when can I make a palindrome? Is that what I need to answer? When is the things? Okay, if I see this one, correct, I can try to what is just greater number than this, which is a palindrome. I can add 1 here, I can add 1 here, but also I can maybe, that's just greater, right? And what is just the lesser number which will be a palindrome? Lesser number, right? Subtract it by 1, so you are going to get something like this, and then I can just say that okay, this one is making a problem, this one is actually making a problem. I will be like okay, then I can fix the problem by just doing 0, making this 0, correct? Is this going to be the just minimum number, which is a palindrome? Because this is equal, only this is not equal, so I'll have to make not this equal to that, but okay, yeah, I think this might work. I don't know, because right now I don't know if it's actually giving me the just smaller or just greater number or not, which is a palindrome. That's what I am currently not able to process. Yeah, so let's say, for examples, let's say I have something like 10 something gibberish. Okay, now what is the greater number? So I am seeing I can add 110. It's never going to be. So I'll be like okay, you want to find the just smaller number which is equal. You'll be like okay, this is equals to, this is 1, this is 0. I'll be like we need to change this, correct? Okay, so we are going to start from the middle. Okay, what is the middle of this? 1. And now you come across this guy and this guy. These two guys is what you are seeing right now. And you will be like okay, now I need to make it just bigger, then I can just fix this with 1. So I'll make this 1, and then again I come here, I need a bigger one, so I'll make this 1. Well, but now you can see that this is 0, but this is not 0. When I want a bigger one, then I'll probably make this also 1, which is not what I will want, because this is This is literally not what I want. Correct. I need to come up with something different. Okay, something gibberish again. So what do I really need to do to actually get that? I need to make as much less as possible. I think I cannot, if the one is on the left side, I cannot make this guy 0, right? Because then it is going to be huge down. So I'll make the right 0 1. So, and if there is a 0 in the left side, I'll make the right side 0. So I'll always deal in the right side. Okay, that's what I'm going to do. In that way, I think I'll get the minimum answer. So for example, if I have this 5 guy, I can see that, okay, I'm always going to change the right side. So 1. Okay, and then okay, I'm here. Correct. I'm here. I'm always again going to change the right guy 0. So as you can see, what happened here. So I added 1 and then I subtracted 2, or maybe whatever you call this. This is all right. This thing is, I mean, I've not subtracted 2. I used, because this I subtracted 1 from the other guy, and like the number of operation actually decreased by how many operations? There are many operations that I did, right? 2 is, I subtracted 2 from previous one. So overall, this is going to be the, so I'm here now, and then I'm here in this guy I see this is 0. I'll make this one. So this is just 8, right? So I added 8 operation. Correct. And now I can see that everything is well how it should be. So this is going to be the total operations that we'll have, which is 7, in order to make that particular number which I just showed equal. So I'm always going to deal with the right side. That's what my thinking is right now. Let's see if this thing works or not. If I can. So let's try to try run. I have a 2 here. I'm always going to make 1 here. This is easy peasy thing. So it will give me the correct answer. Let's try to do 12. Okay. So 12 is just 12 is just 8 plus 4, which is also, we can write it like this, I think. Right, this is 4 and this is 8. And how can I do that? Okay, I'll always change this thing. So this will be converted to, eventually with my algorithm, this. And what is the difference? It's 3. So this is giving the correct answer. 7 is already a palindrome. We don't need to do anything. 6. Alright, 6. Let's see, 6. 6 is just 4 plus 2, which is 110. And I can just, this is working, these are working on this. So let me just check if this will. Also, if you look at the numza, you could have easily just done the brute force approach. I don't know why I am doing this, but I don't know if this is going to work or not, because it's sort of a greedy way, and I highly doubt it. Yeah. Yeah, I highly doubt it. Really, because I really don't know if this is going to work or not. Because I'm always trying to add or subtract once. So yeah, I don't know if this is going to work, but yeah, let's see if this works or not. So yeah, I'll start with I'll try to get to the end of the first thing. So how can I get to the end? Like I want to, so how can I get to the end of this? So let's say I have some binary number. I want to find out what is this number, right? Which place is this number? So generally it's all basically a 32-bit thing where these are all zeros. I can just count the number of zeros, correct? And then total is 32, and I subtract 32 with this, I'll get that. So I'll get this position, 32 minus this, I'll get this position, but I also need to subtract 1. So eventually this is going to become 31 minus built in pop count. Okay, it's not pop count actually, it will be count leading zeros of nums of I. And when I count the leading zeros, after I count the leading zero, I am subtracting 31, and then whatever the answer is, I'll be just like, okay, 1 this. Maybe LL, I don't think LL really help this because these are end values, so this is really fine. So this is the left pointer that I'll have, and then right pointer is obviously just 1. So while L is less than R, I'm just going to do this thing. When they are equal, I just stop at that point. So yeah, I'm going to also have the vector answer, vector and answer of n. And yeah, what am I going to do? I'm going to be like, okay, okay, I think instead of doing this, I'll be like, I should not do this. Only this is fine. Only this is fine. I'll handle it here. So if nums I, and when I try to decrease it by L, correct? So when I try to decrease it, so remember this is just 1 minus that. So I will reach to the very end, and this guy is just going to be R plus plus and R minus minus. That's what I'm going to do. And yeah, so when I bring nums I down, and then I check if nums these are not equal, nums I, or maybe whatever that point is, also I'm going to have 1 and 1, because this is not equal to nums of I. And okay, so I am at rth position. Okay, yeah. So let me do this thing first. Okay, because R is actually always lesser for some reason. Okay, now I think it will make sense. R is 0 at the end, and this R is going to increase, L is going to decrease. That's what it's going to happen. And I'll be like, okay, nums of R and 1. I'll be like, okay, if they are not equal, I am going to add to the answer. What am I going to add? So if this is 0, I'm going to add. So if this is 0, I'm going to add. If this is, so I'll obviously just try to be like add -1 times nums of I, or maybe I should create a variable or something, right? And no, I don't think I need a variable. So what am I going to add? That's the thing. So if this is a 0, then I'll add 1 and I'll move it to that particular position, and then I'll add answer to it. But if this is a 1, I'll decrease that with this. So let me create a separate variable for this one. int maybe x is equals to this whole thing, so that I don't need to do redundant calculations. Okay, so I'll be like, okay, now if the x is just 0, then I'll be like, okay, don't, and then I'll be like, okay, now what we do? Now I'll do nums of I, or 1, and I move that to R, and that's it. That's what I do. Correct? This is exactly what I'm going to do. Right. So this, when this is not equals to x, yeah. So this is what I'll do, and then I'll be like, okay, when I'm finished doing it, whatever I've done, if they are equal, I just don't do anything. I will like, okay, R plus plus and L minus minus, and then in the end I just return ans. I don't know if this implementation is correct or not, but let me see if it will pass. Okay, I didn't create the variable for nums. Yeah, let's see if this works. So okay, so it's not working for some reason. Yes. Okay, I think I've created the something wrong here. Maybe, I don't know. I'm like, okay, this should have worked. R is 0. Okay, R is 0, right? I'm doing this when x is 0. Okay, yeah. So because x is 1 and I'm subtracting this guy. But when x is 0, because these are even numbers, so x was always 0. So when x was 0, I am actually adding 0 to it for some reason. Yeah. I think I got. Yeah, maybe I should just do this instead of doing so much trouble. I will like, okay, just equals to answer plus, so x is 1. If it's 1, then I'll like subtract it or add it. Yeah, that's it. Yeah, I need to do this, right? Yeah, so now it's working fine. So yeah, let's try to submit this. I don't know if this is actually okay. It's giving wrong answer. Okay, I'm doing -5 for some reason. Okay, I think the thing is in the end I'll be like, answer of I is just AB as an answer of I, right? Because it can be negative as well, and because I'm subtracting, I just need the ABS value. Correct. Let's try to submit it again. Okay, now this is something different. Yeah, I thought this type of greedy will work, but I don't think it is working. Correct. So it is 3521. I think it's 32 bits. Like it's very difficult to answer what 3521 actually is. Well, I know okay, 2 to the power 11 10 is 1024, and 2 to the power, so 2 to the power 11 it is going to be 2048, and 2 to the power 12 is going to be 40. Okay, just multiply this by 2, and this is just going to be 4096, I think, right? So it's already bigger, so I'll take this. So 2 to the power 11, so this 3510 is just going to be 2 to the power 11, and if I subtract it, I will be left with, what am I going to be left with? Okay, let me subtract these two things. I'm going to be left with okay, I'm going to be left with 3 in the 3. Okay, and then I'll be like, okay, there's 5, so 5 and 7, correct, and then I'll have 1 here, so it will be 4 and 1, and then I can just put a pen in it. Now this will reduce to 1 is gone, 4 is gone, so this is just going to be 4. It should have been 5, but it will be 4 9, correct. Now it is becoming simpler. If you look at 2 to the power 9, it's just 512, and 2 to the power 8 is just 2 to the power 8 is just 4 to the power 4, right, which is 64. And I'll be like, okay, subtract 64 with it. Okay, so I don't want to be very tedious, and I don't want to do all these things because it's never going to be almost bigger than the power of 2. Okay, yeah, so if it is a 5000, let's say, so then it's never going to be bigger than the next power of 2, correct? So in the worst case, let's say the num size is 1, and he has to go all the way up to, or maybe even if it's 5000, or maybe some weird number. So even if you have some weird number, okay, I also need to check for the palindrome. Maybe in the answer I'll not add these, instead I'll try to add the not. So x, let's say this is y. Let's say this is y. What I'll try to do is, I'll add this, whatever y is, I'll just add that, and I'll add the not of x. Okay, this is what I'll do. After that, I am going to do abs of answer I minus nums of I, and let's see if I still get this. I think I am still going to get, okay, hell, this should be, I think the approach that I am doing is definitely wrong. Yeah, it's definitely wrong. I don't know what is this. One operation. What? You need a one operation? Wait, what is this? Okay, yeah, I forgot to do this. If r is equals to L, I'll be like, okay, answer of I plus equals to nums of I are and 1 R. Whatever I get, I'm just going to add that thing. Zero 153. Okay, wow, that's something. I think this is what I need to work on, because because the thing is, if it's not the thing, then I'll be like, okay, answer of I plus equals to okay, y times L is always going to be the thing, so it's just okay, I'm going to leave this, and then in the here what I'll do is Okay, now I'll be like, okay, this is happening, correct? But if it's not that thing, I'll just do this. Now I think this should work. Yeah, 5, but this is still not working, so my approach is really wrong. Yeah, so what can I really do now? That's the main question, and I don't know why is this giving a wrong answer. Okay, so I can only do brute force now, correct? Because this approach is wrong, and I don't know for what reason this is wrong, and for this reason this is wrong. So I'll be like, okay, and I don't know, like power of 2's. So if at worst case, if something is 2 to the power 31, I'll have to check for 2 to the power 30 cases. But it's 5000, correct? It's 5000, so which is almost around 2 to the power 12, correct? 2 to the power 12. 2 to the power 12, or maybe take 13 for instance, or maybe 14. So at the worst case, I'll have to check 2 to the power 13 cases at max. So brute force is actually going to work, and I didn't do that. Anti-minimum, which will be for now, int(x) is just going to be nums of I, right? And I'll be like, okay, for minimum what I need to do, maybe I'll try to find it in a single go. Okay, so for minimum and maximum, I'm just going to add and subtract to x1. So while x1 is not palindrome, and now let me write a function for palind. So palindrome function is just going to be, okay, wait, let me just copy paste the thing that I did before. Okay, so this is the palindrome check that I'm going to copy this. What palind? Okay, I am very dumb, to be honest. I'll just copy this, all things. Okay, there is something fishy here. Okay, let me copy this, and again I'll delete all these things because I don't really require this. Okay, so the thing that I'm going to do is I will try to find the minimum number, and I'll try to find just maximum numbers. Okay, and so x1, the minimum number will be with nums1. Okay, so now what I'm going to do for while not palin, this is the thing, while not palin of minimum, so I'll have and x, and this will be x, and I'll be like alt or control, maybe. Yeah, control is a control. And there is no answer, so x. Okay, there is already x variable, so I need to have z. So wherever the z x, so I'll convert it to z. Yeah, these are also z. Okay, so I don't need to change this, and I don't need this answer. If the parity of x is equals to y, return false, and when it has done all the things, return true. This will be log n. So while not parallel minimum, I like minimum minus minus, and while not parallel maximum, I like maximum plus plus, and once I find it, I'll be like okay, answer of I just equals to min of abs of nums of I minus minimum comma nums of I minus okay abs. Why am I doing abs, writing abs all of the time? Nums of I minus maximum, right? Okay, I think now this is going to work, but I don't know if this is going to give a time limit exceed or not. Okay, so this will be boolean function. Yeah, I think this should work. It's working. It's really working. I hope this will not give a time limit exceed. Okay, it didn't give. The brute force. I should have done brute force, man. I don't know what I was thinking. I saw the constraint, but I don't know what I was trying to prove. Some kind of genius or something like that. Okay, now in 37 minutes, how can I finish two of the questions? Yeah, but we can always try to do that. Maybe the questions are not, maybe the questions are something which I have seen already. You are given two integer arrays, technique 1 and technique 2, each of length n, where n represents the number of tasks to complete. Okay, if the ith task is completed using technique 1, you can earn this many points. If it is completed using technique 2, you can earn technique 2 points. Okay, alright. Okay, if that task, okay, so if I complete the task with this guy here, I learn this many points. If I complete the task with this, I learn this many points. And you are also given an integer k representing the minimum number of tasks that must be completed using technique 1. Okay, so yeah, this many tasks has to be completed using technique 1, correct? Now the remaining tasks may be completed by using either of the techniques. So I need to return the maximum total points I can earn. Yeah, so if I try to complete it with k elements, that should be at least the minimum of them which I will have to complete. I'll be like, okay, why not just take all the maximum which I can get from technique 1, and then we will see if which of them is actually better. I'll maybe try to have a priority queues for different days. Okay, so the first thing that I'll really do, okay, so how many points do I need to earn? Okay, I need to complete n tasks I need to complete. Okay, and I'll be like, okay, not T1 and T2, like not technique 1, it's very tedious. So I'll be like, okay, what I'll do, I'll be like, okay, L equals to n minus 1, and well, let me have an answer equals to 0. Yeah, it is 10 to the power 5, so priority queue works fine. It was an easy question. See, it's an easy question. So for int I is equals to n minus 1 and I is greater than, okay, I forgot to sort all of them. Sort t1 dot begin and t1 dot end, right? Yeah, now I think now it's fine. Okay, and I'll maintain a priority queue for only t2. Okay, why? I don't know. Just I t2 and t1. Let's say t2 and t1 as well. There is no harm doing that. And I have already completed n minus 1 minus k I minus minus. Okay, so from n to this many, I'll be like, yeah, why not? Okay, so answer will be of long as we can see. So I'll be like, okay, answer is equals to answer plus t1 of I, and I'm going to be okay, that's r1 equals to n minus 1, or I is fine, so that I don't need to write it here. Yeah, I'll do that, and I'll reach at that particular I where, you know, now I'll make a priority queue of max heap priority queue, and yeah, it will be, let's say, long. I don't need long actually, because answer is already long, so I don't need that. Int is fine. Okay, alright, now in the priority queue I am going to insert all the things that is possible. I've already completed k tasks. Now the remaining n minus k tasks I'll be completing from the priority queue. Okay, so pq dot so I don't know if this is actually a thing or not, but let's try. So I is less than n, I plus plus pq dot push, yeah, I think it's push t1 of I, t2 of I, and while I is greater than or equals to 0, pq dot push t1 dot I, right? And I'll be like, okay, once I do that, I am going to just take out from the priority queue itself. So while not pq dot empty and yeah, I've done a remainder which will be n minus k. So rem is greater than 0. I'm like, okay, do this thing. So in the answer I'm going to add pq dot top, and then I'll pq dot pop. Yeah, that's easy. And then I'm going to just return ends and rem minus. Yeah, this should be working fine. The memory limit exceeded. For what reason? What happened? Oh, I forgot to do this. Alright. Yeah, okay. So it's output is 25, but it's giving 22. What? You also given an Indian parametrically using technique 1. I have done all the better tasks with technique 1, as we can clearly see. I just okay, why is it? Okay, let me not use I all the time. Maybe this is why it was okay. Used L now, and yeah, I think this should have worked. I don't know what's wrong. 2 must be completed. I already did 25 with technique 1. Okay, wait, what? Wait, what is the reason I'm not able to give the correct answer? So what is this? 75. Okay, everything is huge number. This is the only correct thing is the example 3, and rest of them are wrong. What is the reason? I just k is equals to 2. I'll just take this 12, and then for the first thing I'll take 10. I'll just take 10, so it will be 22. Yeah, I think now I'll look at it. It's still 75. Okay, it didn't change. What's wrong? What is wrong? Didn't I insert everything into the variety queue? I did insert everything into the variety queue, and 41 as well. So what is wrong here? Or am I, there are n minus k things left, and I'm doing this, taking. Okay, so let's see after this. When I got 22, it will be this, right? Okay, so I don't know what I need to do. So I think you need to do something else. What's the thing? N minus 1 minus k, which is 3, which is 2. 2 minus 2 is 0, and I have to be greater than that, so it's fine again. What's wrong? And in the priority queue I am pushing everything which is there in T2, and then I am pushing everything which is there in T1, right? And what's wrong with this? I am not able to think about what's wrong. Why is it giving much more than it should have given me? Like you can clearly see it's n minus 1, and I must be greater than n minus 1 minus k, which is like literally fine, and minus. It's not even 28, it's 25 for some reason. The output is, how the output is 25. Now here I'll be like, okay, from technique 1 complete these two, which will give you 50, correct? And which is the largest among these. Do the task with, oh okay, I think I got it. I've already completed these tasks. I just need to complete these tasks. So among these tasks I need to take just the maximum, right? Alright, I think I got it. Okay, so whatever I did, this is wrong. Okay, so now what I need to do, imagine 10 to 20 to 30, 55, 15, 25, 10, 20, 30, Okay. Okay, so I'll try to find that particular thing in which 31 is minimum. The first thing that I'll do, I'll convert this into, okay, at first let me give the answer. Wait, whichever is the minimum distance, I'll take that and I'll do all those. So let me do a visited, which means that these are the things that I've already completed. That's what this will mean. And now for each of them, the task, I'll try to find out the maximum difference that T1 and T2 can have, and I'm always going to choose that at first. So let me have a pair, maybe pair or array is also fine, but I'll take pair in this case, which this thing is going to give me the difference between the ith and the index, and okay, this is fine. Vector pair of T1 diff, correct? That's what this is going to be, and this is going to be of 1. So now for all of these things, one thing is sure, that diff dot second is just going to be I, and diff dot first is going to be T1 dot I minus T2 dot I. Okay, this is what I'll do, and then in the difference I'll just sort it, diff dot begin and diff dot end. So when I sort it, the maximum difference is going to be in the end. And now I'm going to do that thing that now long answer. Okay, I is equals to n minus 1, I is less than equals to, or maybe n minus 1 minus k, I minus, and now what I'll do is answer plus equals to diff of I dot first and this of diff of I dot second will be 1, correct? And this is what I'll do, and because I don't want I want a long version, so I'll do this and this. Okay, now once I got this, I'll be like, okay, so if I have not visited I'll be like, okay, base of, I don't need to actually do anything with visited, but if I have not visited it, then I'll be like, okay, T1 of I, max of T1 of I comma T2 of I, whichever is max, I'll be like, add that to answer, correct? And then I just return answer. Yeah, I think at least this. Okay, diff of I dot second and diff of I dot first. Yeah, so now it's 11. I can't believe this. Oh, okay, yeah. The thing is, I will not add diff, instead I'll add diff dot second of T1, correct? This is what I'll actually add, not that thing which was there. 22, yeah, 60, yeah, 15, which is correct. So let me submit this. It got accepted. So now in 20 minutes I'll have to do this thing. So minimum inversion count of subsidiary fixed length. How are given integer array nums of length and an integer? You are given an, okay, so this, and I have given this An inversion is a pair. I know this, what inversion means. Wait. So is all nums of I are different? Are they different, or am I? The inversion count of a subarray is the number of inversion within it. Return the minimum inversion count among all the subarrays of nums of length k. Alright. So I need maybe I can do this thing with square root decomposition. Maybe I don't know. There are not queries, so I can also so for each of these thing I can just do a merge sort, right? So k, because nums of length is 10 to the power 5, I can just do a merge sort on that k and then find the minimum. So this is also easy, you can find it way faster. Minimum inversion comes, okay, this is an easy peasy thing. So let me write the merge sort algorithm. So void merge sort, I'll have two vector, I'll have a vector A, and I'll have the P, and I'll have the Q, and I have the R or mid, whatever you want to call. And I'm going to be like, okay, if P is less than or equals to Q, then only I do, because if P is already equal to Q, it's already sorted, I don't want to do that. Okay, I don't need this actually. Yeah. Now anti R, which I'll be like, okay, P plus Q by 2, and okay, after I do this, I'm like, okay, do merge sort on A of P of R maybe, and then I'll do this. And yeah, I actually want to do something here. I'll do it later. R plus 1 dot Q, okay, and then I'll do this merge, and merge from P to R, P or Q. Okay, this is what I'll do, and there are no inversion if it's just a single number. I return them. I don't know if, like, how can I return the inversion count if all of the elements are same, because there can be same elements or there cannot be same elements. Like yeah, like they have not given they have not given that particular thing. So there can be multiple same, and I have no idea how I can fix that, but yeah, maybe merge sort is also the way for that. So let me write the function for merge. Vector a, and I didn't pass it by reference, so let me pass it by reference. Yeah, anti P, anti R, anti Q, and if I want to merge, I obviously need a temporary variable where I'll store all of the things, and the length of this thing is going to be Q minus P plus 1. I'll have two indexes, I for the temp, I for and J for this guy over here. Okay, so it will be R plus 1, and anti K, which will be for this guy over here, which will be 0. Okay, now I have to do the merge sort algorithm, and yeah, I also need to have some count here, count 0, and okay, so I'll be like, okay, if while I is less than equals to R, and when j is less than equals to q, I'm just going to do this thing. And what am I going to do? So okay, so at first I'll be like, okay, if the first thing is lesser than the second, then I have no inversion, right? Correct. So if a of I is lesser than a of j, I will have no inversion. So temp of I is just plus plus, is just a of I, right? And I'll be like add it as well. Temp of k is equals to a of I and k plus plus and I plus plus, right? That's very easy. But if I find out, even if it's equal, there is no inversion, correct? But if I find out that a of I is actually, now up till everything was fine, but once I find out that a of I is greater than a of j, then the only thing that I can do is I have to make all of them. Okay, so all of them were really lesser, correct? All right, so yeah, I'll have to go towards these guys, correct? So I'll be like, okay, first let me do temp of k equals to a of j. Now I'll have to increase the count by what? So what is the size of the first guy? It's r minus whatever the total thing is. The total thing is I plus 1, right? R minus I plus 1 is the total number of length, and that many, it's lesser than that many number. And now I am just going to be okay, do k plus plus and j plus plus, right? This is what I am going to do. And in the end I'll be like, okay, while I is less than equals to r, now if j is already done and I is the one, then there is no problem in doing the thing. So I'll just do it normally. But if it was the other way around, correct, if j was lesser than q, so I'm done with this whole thing, I just need to do this, then also there is no inversion, right? I'm just fine with this. And then I'll be like, okay, I need to obviously sort this guy. So I'll be like, okay, so for anti I equals to 0, I is less than temp dot size, which is p minus q minus p plus minus q minus p plus 1, correct? And this is the size, so I don't know it to be okay. Now I'll be like, okay, if once you do that, I'm like a of I is going to be, sorry, I plus p, so it will be temp of I, and then I'm going to just return the counters. And let me do this, and I'll also have a counter which is 0 here initially, and I'm also going to do this. So count plus equals to this, count plus equals to this, and when I merge I'm also going to have some more counts, and then yeah, I'll be okay. I'm also going to do, maybe I'll put this outside or maybe not, I don't know. Return 0 and return count here. Yeah, so yeah, now what I'll do is for, yeah, okay, one thing I forgot. It will be something like always going to be k times k. And okay, I cannot just and then if I sort it, then I'm done, I'm doomed. I just wasted this. I cannot sort that particular thing. When I sort it, I'll be like, I'm gone. I need to make a separate array for this to work, correct? Right? And how do I do that? I cannot really do k times plus how many sub-arrays are going to be there, almost like n times k. I cannot do that because k can be as large as a k. Okay, can be as less as k 1 n times k. Can I do n times k? That's the thing. So let's say at worst case k is going to be n by 2, then what will you do? N times k is n square, so you cannot do that. So this is also, you might have implemented this correctly, but the thing is it will not work here. So you need to do something else instead of doing a simple merge sort in order to count the inversions. So how can I really count the inversions? With merge sort is very powerful, and you can also do some other stuffs as well, just not inversions, but also some monotonic things I'll show you later. But yeah, you can do that. But this is just waste. I have no idea now how can I do this. Guess I'll need to watch the tutorial for this. Minimum inversion count among all the subarrays of length k. So what do I do? N times k, I cannot afford it. Interesting question. Actually, I think I'll have to learn something. Okay, I think I won't be able to do it, so that's it guys for today. Yeah, I hope you liked it. I don't know what my rank is. My rank will be pretty bad, I think. Let's see. Yeah, it's very bad. So yeah, I wasted a lot of time in question 2, which, like, I shouldn't have implemented, you know, the greedy approach or whatever I tried to do. I should have directly did brute force. But yeah, it just happens. And in this case as well, if I look at this,